Here waiting for everybody. My name is Ed Catabaugh, aka Spatial Ed, if you've ever seen my blogs before. I have with me two of my colleagues. Both are program managers like myself. We have Olivier Meyer from the SQL Server Strategy and Architecture team, and we have Torsten Grabs from the Stream Insight team. And we have a couple of pretty interesting things to show you here today. Before we do that, however, I'm going to give you a quick little rundown through SQL Server Spatial, and then we're going to do some decidedly non-SQL things with the SQL Server Spatial library, and I think you'll find this very interesting. Okay, this is my slide. Feedback. Now I'm off, I'm back on, good. This is my slide. If I had one slide to show you on Spatial, this would be my slide to show you. And of course we divide it into 4 parts because that way I can get away with only one slide. How many of you are familiar with SQL Server Spatial? And Morton, you don't get to raise your hand. Excellent. Anybody used the SQL Server Spatial library before? Very good. So I don't have to go through this slide in a particularly great detail, do I? Everybody knows everything on here. But let me just do a quick refresh. We've got SQL Server Spatial types in 2008, R1 and R2, obviously. These are all open geospatial, simple features for SQL, compliant version 1.1 implementation. So we've got data types, 2 of them, a geography and a geometry. Geography for round Earth, ellipsoidal Earth. Geometry for flat Earth, this would be X and Y coordinates. The former, geography, would be for latitude and longitude coordinates. So we'll take you through some of this stuff in a little bit here through some of our examples, but what we've done is we've written a library, and this library is implemented as a DLL. It is an assembly with which we use it for all of our type and method support in SQL Server. So because SQL Server Spatial has been implemented as a CLR UDT, this means that we had the option of making this library externally available, and indeed we have done just that. So we'll move on to the next slide here, and we can take a look here at a little bit of the resources. If you go into the feature packs for SQL Server 2008 and for the new R2 release, you can discover way down on the list 3 packages here. And it includes the hierarchy ID type because that also is another CLR type. This particular package is exactly what we use internally, but we've made it available at no cost. It's freely usable, freely redistributable. And with this, you are free to build your own applications that are going to be very similar to the ones that you have seen Torsten and Olivier build here in a few minutes. Additionally, since we have not documented this particular package very well, in fact we haven't documented it at all, we have given you a website, a Codeplex website, and you can search it on SQL Server Spatial Tools, find the website, and you can download a bunch of examples. There are 2 APIs, a sync API and a builder API for this type, and we give copious examples using all kinds of interesting spatial things that we did not get time to put into our standards compliant release. Now, many of these same things that we're giving you source code here today in this particular site, we will make available in the next generation release in a couple of years. But in the meantime, this is a place where we can get your feedback and add in new functionality. All right. Now, a few things that we're going to be doing to the spatial library in the next release. 2D enhancements. We had a pile of things that we didn't get to that were on the Codeplex site. We'll be putting those into the library itself. We're also implementing, for the first time in a relational database, full globe support for geospatial objects. So this means that you can have an object defined as a whole globe if you wish, or you could have the world's oceans, something that occupies an extremely large area, and you can run, of course, all of our methods and do all the indexing on top of this. So you can look forward to that coming. And lastly, and we're not committed to this yet, we're looking at putting in a terrain mesh type. And this would give us some triangular mesh type that would give us terrain support. So we'll be able to to do things potentially like view shed analysis, slope and aspect, and a few of those other interesting spatial aggregates. Okay, so things are subject to change here. No commitment that we're going to do this, but we most likely will. So those are some things coming. Okay, with that, we're going to introduce Olivier Meyer, and Olivier is going to go through I think you'll find this a very interesting demo, but before I introduce and actually get him to do this, let me explain a little bit about how this particular project came into being. We had one of our lead engineers, in fact, he's the mathematician responsible for the spatial library, said, Ed, I want to have a demo developed in which we take the SQL Server spatial library, let me emphasize SQL in here, and use it in a non-SQL environment. So with that, I went to Olivier and said, I need this application. What can we do here? And so Olivier then created the following.
Thanks, Ed. So Ed came and he said, you used to be a developer, right? Maybe you can do something with this library. So I'm reverberating a lot. I decided, well, you know, people like triangles, so why don't we show them an app that can calculate the area of a triangle? I think we can't be close to each other. I turned it off. And so anybody find this exciting? Anybody remember how to do this from high school, junior high?
Let me interrupt you. Let me interrupt you.
This is a complex problem.
It is a complex problem, but this is decidedly not what I had in mind. So with that, I said to Olivier, you need to go back to the drawing board and think of something that was a little bit more interesting and entertaining.
Okay, but I still think this is cool because you can take a triangle and you can buffer it.
Tell that you're a developer.
All right. So I went back to the drawing board and said, well, other ways people like to calculate things is with Excel. So why don't we see what that might look like to an Excel user? So hopefully everybody can see this. And I'm going to ask for a volunteer. Anybody here travel from the East Coast? Where are you from? All right. And I'm going to spell it incorrectly probably, but anybody travel from the Midwest? Where did you come from? Stevens Point? So it turns out that most people who use Excel don't start off with a spatial data set. You know, it's, see? Like that? And so it'd be nice if we could let Excel users transform their normal data into geospatial data. And so I'm asking Excel to tell me where on the world is Burlington, and I'd like to be able to do some normal Excel stuff like copy and paste. So now I've transformed what most people have, which is addresses, into geospatial data, and then we can start doing some cool things. Let's say you guys wanted to know how far you live from each other. And of course, you'd want to know that in meters, but we'll divide that by kilometers, or if you're not from Europe, miles. But you get the idea. So now let's switch to something a little bit more complicated. I have a different spreadsheet that's already loaded with some spatial data, and that's the countries of Africa.
Now, I want to interrupt you just for a second. This is exactly what I had in mind, by the way.
Oh, is it? Cool.
Yep, so, you know, you didn't take a third time. At least it only took you 2 times to get it right.
Thanks. I appreciate that. I should mention we have this really cool book here today that was co-authored by one of the speakers who wears a cap. We're going to give this book away to the person who can guess the area of Morocco the closest. So anybody have any guesses for the area of Morocco? What's that? Put it in map, what? Yeah. So I'd like it in square meters if you could. Square kilometers will work. 446,300 square kilometers. I have this weird feeling that you might be right. I don't know how to. So if you were an Excel user, you might want to say, hey, what is the area? And then you might want to divide it by a million, probably, for square kilometers. And was that close to what you said?
403.
All right.
Google was wrong.
Oh, excellent. I think since that was recorded, you definitely deserve the book. So we'll give it to you.
Just remember to read chapter 14 first. Okay.
All right. So now we want to be able to do things like an Excel user would, which is kind of drag. And so I think this is how an Excel user would want to do spatial analysis. But we can do some more interesting things like find out if a country borders another one. So we're just going to intersect Morocco with itself. Oops. Yep. This is just to give you a taste, but I can use fixed references. That should still be true. And then I can buffer, which means I'd like to grow the country by just 100 meters or so to make sure it intersects its neighbors. Just to give you a taste for the types of operators that you have. And then I can say, okay, well, tell me what does border Morocco. And then I find a couple countries that do. And this is where I stopped, right? I have a whole bunch of spatial functions, and then Ed, who left the stage, said that's not really good enough. This is cool, but it's not really good enough. So what people want to do is maybe see the countries. So I'm like, okay, cool, I'll do it the way an Excel user would do. If it's true, then I want to show it. If not, don't show it. And I'll just do that again. And so he wasn't happy with that either. I mean, I'm showing you the countries that border it. But what he wanted to see was something like this. And if I had done it right, he would have seen it. But that's what he wanted to see. So I think that's pretty cool. I'm kind of, all right. So as a program manager, my job is done, but as a developer, I'm guessing you guys kind of want to see how this actually works. Is that true? Yeah, okay. So we're gonna get out of Excel, and I'm gonna launch Visual Studio. And I'm not gonna show the full project. I've started blogging about the full project, so you'll be able to get all this code and see how it was actually done. But just for this presentation, given the amount of time we have, I'll just show you a little bit of how it works and give you the gist of it so that you can follow the blog. So here I have a very complex project. It's got a few functions. And the things that you should know is the way to add functions to Excel, there's different mechanisms, but the one I chose was to build a COM automation object. So I don't know, many of you used to do COM and DCOM a long time ago. So iDispatch, automation, all that stuff still exists. It's just hidden from you, and .NET does a lot of heavy lifting for you. So all you need to do to turn a normal .NET class into a COM object is to add this line. And all the auto-dual interface type says is tell .NET, I want you to be able to support kind of late binding automation type methods. Here's a couple of helper methods to just register this in the registry. I can show you what that looks like. It's just putting a particular value in the registry. So here's the key part. Here's how you learn how to use the spatial library. First, you need to include this assembly. The Microsoft SQL Server Types library includes the spatial types and a couple other CLR types. But the important part is here. So you have a SQL geography type. And when Excel calls my add-in, it's going to pass to me whatever I put in that cell. And in this case, it's a string representation of a geospatial object. So I get that string as a shape. And then I call the helper method on the geography object to turn that text representation into an actual geography shape object. and then I can call the standard function stArea to get that value, and I return it back to Excel as double. What I've just shown you is the heart and of how most of the add-in I showed you earlier works. And so it shows you that really with 3 lines of code, you can do a lot with the spatial library and with Excel. Now, I'm not showing how I do the cool map and all that stuff. You'll have to read my blog for that. But the next step is to then act on ranges of cells. And how many in here have done VSTO add-ins? So you're somewhat familiar with the Excel object model. The next step is really to get a handle to the Excel object model and to the Excel application, because then your add-in can start driving Excel, and it can start talking in Excel terms. So Excel ranges, intersections of Excel ranges. I don't have it in this simple demo, but on the blog I'll show all that. But I just wanted to get kind of the quick message of how easy it is to incorporate the spatial library and get some really cool stuff done very quickly. So I don't know if I went quickly or if you guys have any questions, but we can take questions at the end. But if there's a quick question, I'd be glad to. You know, it's a good question, and I'll have to get back to you on that because I haven't tried it. But I don't think it would work because, right? There's half the library is native calls to Windows, and so I wouldn't imagine it would work. But oh, sorry. The question was the use of the spatial library in a Silverlight application, and it doesn't currently work because the actual library is about half native code, half managed code, and it makes calls to the Windows operating system for doing kind of high-speed calculations on graphical objects. So I don't have a good answer for you, although I'm sure we're looking at how we can enable and light up Silverlight with spatial objects. Sure.
You mentioned that conversion from addresses to coordinates.
Yeah. It was magic. No, what I did is so I added another method called parse and locate, exposed it as a callable object, and then I called the Bing Maps web service, and I do geocoding. One of the other functions I'd like to add is geocoding of IP addresses, because people have a lot of web traffic and they'd like to kind of plot what's. But yeah, you can do anything you want. In this case, I used Bing Maps or MapPoint. That is, it's free to us, but yes, that's true. But there are, I think there are probably some free services out there that you can use, and then I can look into what the actual cost is for a developer. I think developer licenses are free, but production is not. So I'm going to hand it over to Torsten, who's going to go in a completely different direction with the spatial library, but to just show you the breadth of types of apps you can build.
Do you want to show the...
I'm going to kick it off for you. Do you want to set it up?
Let me log in here real quick. Should we switch? It's on
C.
C. So what you're seeing here is an animation of the shuttles that are driving through the Microsoft campus in Redmond, very close to the buildings where we are working. And the idea that we got was, hey, wouldn't it be cool if I'm waiting for my shuttle, if I could receive a message, basically, when the shuttle comes into the vicinity of the building that I'm working. So I get a 3-5 minutes heads up, and I can leave my desk, and I'll be ready when the shuttle arrives. So the interesting question here is it basically requires us to consume data from the shuttle services about the location and the direction that the shuttles are traveling, and also have some spatial information about the different buildings on Microsoft campus. And basically, that would be a query that I'm running over these two different types of data. And as soon as my shuttle comes close to the building where I'm working, then I want to have the ability to fire an alert. And that was kind of the starting point for us to look into into an interesting combination of two different products. The first product we have already been talking about for the last couple of minutes, the SQL Server Spatial libraries. The other product that we are working on right now for the SQL Server 2008 R2 release is called Microsoft Stream Insight. And the product is targeted at scenarios where you are receiving data feeds from data sources such as sensors, and you want to process them with low latency or close to real time. Let me tell you a little bit more about these kind of applications that we are targeting with Microsoft Stream Insight. The starting point for us coming from the SQL Server product unit was where the database applications. We understand those applications very well, and we've been working for them, and we have been providing the platform to build these kind of applications for the last decades. These applications are typically characterized by acquiring the data, putting the data at rest, and then doing the processing over the data. So the typical application submits a request, can be a transaction, can be a SQL query, and then gets the result back. So that's the typical way how database applications interact with the data. Two other characteristics are important. If you think about response time and throughput, those are very key performance characteristics for database applications. What we typically see is, depending on the application scenario, you would deal with response times in the order of fractions of a second to hours or even days for long-running reports for database applications. The typical throughput characteristics are around hundreds, if not thousands, of transactions per second that you are processing in the database for your database application. So this was the point where we were basically a couple of years ago. And as we were engaging in customer conversations, we learned that there's a different type of applications that are not served well necessarily by database systems as the underlying platform. So what are the key characteristics of those new applications that we discovered? The first one was the observation, the way how the application interacts with the data is completely different from the way the database applications interact with the data. The main observation here is that you have data sources that are constantly generating and emitting data. What you want to do is you want to acquire that data and constantly run queries, constantly process the incoming data. And as soon as you have received the data, react onto what you see. This can be that you have certain patterns that you define, and if the incoming data exposes that pattern, you want to react. It can be that you have thresholds that you define, and as soon as the incoming data exceeds the thresholds that you have put into your application, you want to generate an alert, you want to send an email. So those are the typical scenarios that we see, and that's the typical way how those applications want to interact with the underlying data. And that's typically very tough to do with a database application because you first have to persist the data and then with a certain frequency or rhythm, rerun the same query, the same report again and again and again. And this is very costly if there are no changes in the underlying data. And it's also wasting resources. So in terms of the response time and throughput characteristics, for those new applications that we call event-driven applications, we're talking about latency and data rates. The latency is the time that it takes from an incoming piece of data to emerge in the results of the application. The second one, the data rate, is the amount of data or the number of events or data items that your data sources produce per second. What we now want to build with Stream Insight is a platform for those event-driven applications. The platform should allow you to build your event-driven application for your domain, for your industry, similar to what database systems today do for data that you put at rest and process then. Let me give you a little overview about the product. If you look at that slide, that's basically the 10,000 feet perspective onto the Stream Insight product that we're building right now for the next release of SQL Server. The slide is structured into two parts. The first part is a top part that you see here. And it describes the application development experience that we are providing with Microsoft Stream Insight. And a very fundamental design decision for us was to render the development experience through .NET. So the way that you write your event-driven application for Stream Insight is through using Visual Studio. You write your application in C#. And the way that you write your queries, your rules, your patterns that you want to process continuously over the incoming data is through LINQ, Language Integrated Query. Once you have written the application, you build the application, you run the application, and once you run the application, the link queries for Stream Insight that you have written in your application, they get compiled and registered with the underlying runtime of the Stream Insight product. And that's the second half of the slide, the bigger half of the slide, where you see the complex event processing engine that comes with the Stream Insight platform that hosts the standing queries, the continuous queries that are constantly running and constantly observing the data that you are acquiring from the data sources. So if you look at the runtime, the overall flow of the data is constantly a feed from the left to the right, from the event sources in this slide to what we call the input adapters into the queries that are constantly running, outputs being generated as the events come in, and then the outputs go through the output adapters into various different event targets. Some of the key properties to keep in mind to make sure that you can connect to your domain-specific data sources, we provide an SDK for input and output adapters, a well-defined API that allows you to plug in your domain-specific data sources into Stream Insight, and then through that well-defined API, and queue new events, new data items as you receive them from the data source for processing in the Stream Insight engine. The Stream Insight engine provides you a runtime that automatically picks up the incoming events as soon as you haven't queued them from your adapter and automatically kicks off the processing. So you don't have to do anything. It's automatically triggered, and the processing is continuous, and it's incremental. So it's very efficient. We need to do that incremental processing to keep the latency as small as possible. So how can we use this for the application that we were describing previously? So imagine that one of the data sources on this slide is actually the tracking information from the various Microsoft shuttles. Can come with a timestamp, an ID of the shuttle, and then information about the location and the direction and the speed of the shuttles. So that would be an event source, basically a sensor that runs and travels with each of Microsoft shuttles. The data that we are acquiring is being fed through an input adapter into the Stream Insight engine, and then in the Stream Insight engine, we want to do the processing to find out, is this shuttle coming close to building 34 or 35, which turn out to be the buildings where we all work. Now, that would be an interesting query to do, because we have to write a link query for Stream Insight and refer from that link query to some spatial processing to find out whether the shuttle is coming close to building 34 or 35. And this is exactly what we tried to do. For a couple of days of operation in early 2008, I have the data here. I brought it with me in an Excel spreadsheet on my laptop. It's more than 500,000 data points, 500,000 sensor readings from the various different shuttles that were traveling on the Microsoft campus throughout those days. And what I want to do is write an application that consumes that data, pumps it into Stream Insight, and spits out how often, within a particular amount of time, shuttles came close to building 34 or 35. Oops. So let me switch over into Visual Studio, and let me first walk you through the application. The main project here is the shuttle tracker project that you see, and it's very simple. It just has one file, the program, and we're going to walk through that. In addition to that, it refers to a couple of other interesting pieces. The ones that you see up here, the first one, you're already familiar with. That's the reference to the SQL Server spatial data types and the spatial functionality, the same one that Olivier just used in his demo. In addition to that, you also see that there are three other references that we have, which refer into assemblies that come from Microsoft Complex Event Processing. Those are the assemblies, those are the DLLs that come along with the Stream Insight platform. So an interesting observation from that is that actually for this demo that we built, we are running the whole Stream Insight engine in process, in the application. We embed it in the application. So there's no need to install or refer to other SQL Server products. As soon as you add those references to Microsoft Complex Event Processing, you will get all the functionality for Stream Insight. So in that respect, it is actually very similar to the SQL Server Spatial libraries. In addition to that, let me walk you real quick through the application and give you a sense of what it does before we go through it in depth. So one of the first things that we do is to set up the input streams, which we do with this function here, shuttle location stream. And then you see a whole area that I'm just going to highlight at this point because we're going to go deep into that in just a second. Is this where we are building a query over the incoming data stream from the shuttles and the locations of the buildings and doing all the checking and all the counting. Once we have written this link query, we are registering that with the Microsoft Stream Insight engine, and we are starting it processing all the data. This is down here, waiting for all the data to be consumed, and then we're shutting down the query. So that's the overall flow of the application. I register my data source. I describe the data type that I'm acquiring from the data source. I write my link queries over the incoming data. Once I've written the link queries, I register them in the Stream Insight engine, which gives me the ability to start the query. Once I've started the query, it sits in the Stream Insight engine. And as long as data is coming into the engine, it's doing its processing. Once I'm sure that I've consumed all the data, then I can stop the query and shut down the Stream Insight engine. So let's run this thing real quick and see what it does. So you see that we are creating the input stream, and you see already that as we are plowing through that file, we're receiving events that describe the shuttles, their arrival times in a specific window of time, the number of shuttles that we have seen. Let's relate this real quick while the data is coming in as we plow through the file. The file is several megabytes big. Let's have a quick look at the input data. So this is how the input data looks like. The first column here is the ID of the shuttle. The next two columns are the location, longitude, and latitude of the shuttle at this point in time. That is described with these two columns here. This is a date, and this is the number of seconds after midnight for this date. So these two give us the time information, a timestamp, a date, and a time. These two give us location, and this one here is actually the direction. So for some of them, it's 0 because the shuttle is just parking somewhere. For others, it's northwest or south, depending on which way they're heading. This column here is the velocity, the speed at which the shuttle is traveling. So that's my input data. How am I using this input data? The way that I'm using it right now is that I'm feeding it into a query that for each 1 hour window during a day computes which of those shuttles that we were just looking at in the Excel spreadsheet were in the stop in the parking area for building 34 or 35 on Microsoft campus. There are a couple of interesting things that we are doing there. We are acquiring time information, we are acquiring location information, we are expressing a window over time because we are doing an aggregation over hourly windows that are hopping, and we are also checking for location with building 35 versus building 34. So how hard is it to do that? Let's have a quick look into the guts of the application. So first of all, let's have a quick look at our input definition. So our input definition is done with this function. The event data is defined with this .NET class, which basically reflects the various columns that we've seen in the Excel spreadsheet. We have a direction, an ID for the shuttle, the location information, and the speed. We sat down and wrote an adapter that allows us to consume that information from the file, and the most important events there in this file are basically the points where you enqueue events into into the Stream Insight engine. I'm just highlighting one of them. It's a well-defined API, has about a handful of different functions, and the most prominent one is the enqueue function that allows you to enqueue new events that you have received from the data source for processing in the Stream Insight engine. So now, once we have written this adapter, we can basically wire up the data stream from a specific data source. Here, this data file, comma-separated value file, the Excel file that we just looked at, and define a location data stream over events of this type that we're getting from this file. And this is what we return, and this is what we are writing our functions and queries over. So let's have a look at the queries. The first one is the one that just refers to the location stream that we just built, and then does a very simple projection over it. So it selects the ID, the speed, and the direction. And then it adds the building information. That's this part back, oops. That's this part back here. So how did we do that? Let's go to and look into the definition of that function real quick. Come on, nope. So what this function does, it gets the latitude and longitude from the shuttle as it is traveling, and it refers to this as a SQL server spatial point object. And for all the various buildings that we have defined, we are looking at that shuttle location and are checking with one of the SQL Server spatial functions whether we have an overlap between the position of the shuttle and the area that the building covers. We are doing this in two steps, first with a bounding box, and then where we are drilling down into the actual specific shape of the building. Those are the two if statements that you see here. So very, very straightforward and very simple function. And as you saw, it's very easy to refer to these functions, to a user-defined function that uses an external library from one of the link queries that are being processed in Stream Insight. So very, very powerful, just a couple of lines of code that you need to write to get all this. The capabilities of Stream Insight, the continuous processing, plus the timestamp information, the temporal processing, we'll get to that in a second, and the location depending processing through the SQL Server spatial data types. So let's look at some other interesting things that we're doing. So this is the query that we just looked at. It gives us the building information for each shuttle as it is traveling. This query that we see here is just checking whether we are getting close to building 34. The next step then, for all those guys, all the shuttles that came actually close to building 34, is now to do an aggregate for hourly windows. So for each hour, we want to compute how many shuttles came close to building 34. And that's the next step that you see here, where we're using one of the link extensions that Stream Insight provides for doing temporal things like hopping windows, tumbling windows, sliding windows, and snapshot windows. And once we have defined those windows, we can reason about sets of events that fall within that hour that we have defined, and then do the counting operation over it. And that's the last step. After that, we are just taking that query, registering, and running the query. OK. So let me see. Go. Good. This is all I have. Are there any questions around Stream Insight that we should answer at this point? Yes, in the back, please. Can you repeat that? What was the product that you were referring to in the beginning?
Process historians in general.
So the question is about process historians. One of the things that I maybe should have mentioned more prominently is what Stream Insight provides you is a main memory query processor that implements most of the relational operations over streaming data that's coming from the data sources. Plus, in addition, all the temporal extensions for doing the window operations that we were just discussing. It does not, out of the box, provide you any persistence. You can wire up SQL Server, for instance, or BizTalk to the input or the output adapter. And these products will give you persistence. That is also, that's also the way how we would interact with historians' archives. You would need to write an input or output adapter that allows you to consume the input data from a process historian or to actually use Stream Insight to generate more complex events that you then persist as time series information on the output side in a historian. Other questions? Yes, please.
In your program, how do you stop? There was a wait. How does that wait return?
So the weight that you saw is, remember we were processing this Excel file with the input adapter that we wrote. As soon as we have read all the lines from the input file, the adapter just raises an event and we're waiting for that event. And once we consume the event, then we know that we are done with all the input and we can shut down the query. Depends on whether you're consuming historical data. In this example, I had to bring my data along. If you think about a real-life example where listening to the incoming data feeds from the shuttles, you would actually not stop the query. You would have the query constantly running until someone decides to take down the application for whatever reason. Yes, please. Okay. So the question is about how do I deal with different data sources that are delivering data at different speeds. The way that we're reasoning about time is that all the processing that you have seen, all the temporal processing refers to what we call application time. And we make a very clear distinction between application time and system time or arrival time. So all the data sources provide the temporal information from the data source, which is very important. For instance, if you think about a stock exchange where you're receiving ticker information, you want to make sure that all the processing, all the patterns and the sequences that you look at reflect the time from the stock exchange, from the original data source, rather than the time of when the event arrives at the system for processing. So that's a key distinction that we are making, that all the processing, all the semantics of our internal algebra are based on application time rather than arrival time. So for your idea where you have data arriving at two different speeds, it depends on what you want to do. For instance, if you want to do a join operation between these two data sources, what the join operation does, it makes sure that whatever we match from one side with an event from the other side, that they're closely related in time, that they overlap in terms of their temporal characteristics. And that may require you to wait until a certain point in time until you have received data from the second data source. An interesting capability that our underlying algebra has is it has the capabilities to generate preliminary results. That gives you the ability to look into results as events come in, and we'll be revising those results as new events are coming in and we need to adjust the preliminary results. Yes, please. How do you manage large-scale data? In terms of the data rates that we are processing, we're looking at tens of thousands, if not hundreds of thousands of events that we need to process per second. It obviously depends on how complex your queries are and what input and output adapters you wire up with your application. Just to give you one data point, we have an internal collaboration with MSN.com where all of MSN.com's web servers are instrumented such that a Stream Insight engine receives each click, each search query through Bing as an event for Stream Insight processing. The MSN.com team is using that to do low latency, almost real-time customer segmentation to drive ad and content delivery. With that application, we are receiving and processing 500 million events per second. And they are not actually running any other SQL Server product for that specific application other than Stream Insight at this point. They also do save the data, but they're using another product, an internal Microsoft product, an internal Microsoft system to persist the data. Okay. Let me wrap up because we are out of time. I'll be here after the session, so if there are more questions, then please feel free to stop by. Ed, do you want to wrap up real quick and walk people over the resources?
Yep, we can do that. I think everybody can see the resources here pretty well, but we've got my blog at the top. We've got Torsten's and companies in the middle, and Olivier's, I believe, with all of your code that you've put out there for the Excel spatial spreadsheet. You can see a few forums here, lots of activity, quite interesting, and of course you can see our books. There's a good beginning spatial book for anybody who wants just kind of an encyclopedic coverage of it. That's the first one there, Beginning Spatial with SQL Server 2008, and then of course the one we just gave away here is Itzik's latest book, of which I'm the co-author on Chapter 14, Spatial. So any additional questions, why don't you come over and see us? We're going to be in the SQL Server booth over in the main showroom, and we'll be happy to take additional questions there. Thank you all very much.